Okay, Tamis Kanatni. Hello and good morning to all your early risers. Ketok Kanatsi Mokpova. I happily greet you all here from Sikokkotok in Lethbridge, Alberta. And good morning to the Holos model training. I'm just gonna pull up my presentation mode. Yes, so hello, good morning, everybody, and welcome to the Holos model training. I'm just giving you a quick introduction before I hand over to our colleague, Aaron McPherson. So as you probably are aware, the Holos model is what we call a whole farm model to calculate greenhouse gas emissions from Canadian farms, and we're trying to capture all the emissions on the farm and showcase where the emissions coming from and give you the means to explore what management practices would lower these emissions. We keep updating this over time as we learn more. So it's not essentially the final product, but it's basically representing what we do know. This is our small but mighty team. From the very left, Pamela Mantle, our software technician, or our data technician, Aaron McPherson, who you will see shortly, Dr. Sarah Polk, who you will see this afternoon in the panel discussion, Dr. Adil Rashid, who is with us for a term assignment, and then myself as the lead scientist. The Holos model is continued to be developed as part of the idea of being transparent as well as reliable. So if you go to our GitHub repository, you can find the algorithm document with all the equations that are in the code. There should be a match between the equation numbers in the algorithm document and the software code. You can overwrite all the defaults in the model that we provide you with. The idea is here that we don't want you to get stuck with an empty input box. So we have a default there, but ideally you overwrite this with a farm-specific value. Everything that we put into the model is usually based on peer-reviewed science, and we try to align as closely as we can with the National Greenhouse Gas Inventory Report. So as I said, we're trying to capture emissions from all over the farm. So we're dealing with basically nitrous oxide, methane, as well as carbon dioxide. With nitrogen, because it is in the nitrogen cycle, there is basically additional calculations with respect to ammonia loss as well as nitrate leaching, which do cause indirect N2O emissions downstream. So these are accounted for as well. With respect to carbon dioxide, we're basically calculating the change in soil carbon to calculate the balance between carbon fixation and respiration, and then we're adding in CO2 emissions from machine use. Going forward for the upcoming basically model development, we're hoping, and an LOI has been submitted internally for funding request to add in a water budget model as well as add in a soil erosion indicator. We are looking to build out the machine fuel use estimation, as well as our team member Pamela Mentel has reviewed basically other shelter belt calculations. So we're hoping that we can build out the shelter belt component. The model will and is designed primarily to provide you with a farm greenhouse gas budget, because that is where the farmer has basically all the control. And the idea is to essentially explore what if questions rather than what is. So the idea there essentially to play around with the management practices and to investigate what practice actually does impact the emissions. This is somewhat different from the carbon footprint calculation that is often asked for in the supply chains. The Holos model can be used for carbon footprint type analyses, and if you look at the papers that we published, most of them are on these carbon footprints. But it needs a little bit of additional knowledge about basically the question of boundaries of the life cycle system. And this is something I'm hoping to address in future updates to the model to kind of support this type of carbon footprint analysis better. Why go open source with the model? Well, in the past, we basically had always this problem that the model was closed source. So the code was basically hidden behind the IP wall of AFC to say like this is proprietary software code. This had the basically consequence that if we did get feature requests, they could not be considered or there was a long delay. The development cycles were not much longer because also the software code was not agile. And so there was simply sharing and transparency limitations. So with open source and the GitHub repository, and you see a screenshot on the right there, that opened up co-development opportunities, allowed different stakeholders to adopt the model, and that is already taking place. It basically forced us also to discover what we did not anticipate. So if you put things open source, you never quite know what will happen. But I think what we successfully did was basically build trust by building in the open. So in a consequence, in contrast to version 3, where basically we built the model and that was the model you needed to use, the version 4 is more about to showcase what the software can do and all the options that we can basically include as to with respect to what the science knows, but the model is available to be adopted by others. We also can, in this context, provide the lowest common denominator. So the Holos model is a desktop application right now, still Windows only, but that's about to go to change. There's no internet needed, although it is beneficial to download daily climate data. But we don't know what you do with the model because it's on your computer. The data that you input stays with you until you decide to share them. We don't know what happens with that. And so in this respect, I'm putting there, we're OCAP compliant. So OCAP is basically a First Nations course that's offered online on data ownership, privacy, control, and forgot right now what the A stands for. Sorry about that. It is also basically for in-house development cheaper because we don't have to have a web server. We don't need to worry about data security and so on. One thing that we learned is that co-developments are much slower to gain. So basically the hurdle of like getting into and partake in open source development poses a problem essentially for academic collaborators. But we do have companies that work with us and already have given back some things to us in terms of development time and efforts. So one thing that we have learned is we need to establish better version control. That was a bit tricky with version 4 as we basically bounced out into open source development while still finishing up version 4. And so we're looking to basically then update this with the versions 5 and 6. Quick acknowledgement to all the co-op students that helped us over time. So you see a long list for version 4 because it took quite some time to get it out there. An acknowledgement to past collaborators. The QR code gets you straight to our GitHub repository. The email is there and Aaron will post it again. And so with this, I'm basically handing over to Aaron to lead you through the training, and I will see you back once he is done to hand you off to the Ted Poiser lecture. Thank you so much.
All right, thank you, Roland. Good morning, everybody. My name is Aaron McPherson. I'm the software developer for the Holos application. I work here in Lethbridge with Dr. Roland Krobel, Dr. Sarah Pogue, and Pam Mantle. And today I'll be guiding you through a demonstration of how to use Holos version 4. So this morning's session is scheduled for about 2 hours and 45 minutes. So the workshop or the training part won't take that long. So after the training, I'll be doing a presentation on the next iteration of Holos and what that looks like. And included in that presentation, I'll be going through a live demo. So it should be an interesting morning. All right, so before we get started, as Roland mentioned, currently Holos version 4 is only available on Windows computers, but as you'll see shortly, we're working on improvements to that. So unfortunately, if you're working on a Mac computer, you won't be able to follow along. But the format of this workshop is I'll be taking 5 minutes periods of time, guiding you through the software, showing you how to set up the farm, and then I'll pause for about 5 minutes, and then you'll get an opportunity to follow along with your computers and sort of do what I did in the interface. If you have questions, please ask. I can see questions that are asked to me through the chat window. I'm happy to answer questions. Okay, so when you open the application, Holos 4, this is going to be the first screen that you're seeing. It presents the user with 3 options here. You can either create a new farm, you can open an existing farm, or if you have farm files from colleagues, you can import data from somebody else's scenario. So since we're going to be doing a demonstration today, I'm just going to create a new farm. So I'm going to click new. And let's give this a basic title here. And then once you're happy with your farm's name and you add some descriptive comments, you can click OK. So the idea here about giving it a name and some comments is typically over time, you're going to have many farms in your system. And if you add some descriptive comments, it's just going to help you organize your farm and your scenarios a little bit better. So we're going to click OK to proceed. We're going to keep the units of measurement at metric for now. And at the bottom here is where we see our navigation buttons. So I'm going to click next to go on to the next screen. Okay, so our test farm, our demonstration farm for today is located in the province of Manitoba. So I'm going to click the drop down and select Manitoba. And then I'll click next. And then here we see a map of Canada with Manitoba centered on the screen here. And all these little red indicators are polygons, soil polygons of Canada. And if we scroll in, we can see a little bit more detail on these polygons here. So for this demo, we're going to select a farm that's located between Winnipeg and Manitoba, close to Portage la Prairie. So I got Winnipeg here, Brandon here, and we got Portage la Prairie here. So I'm going to zoom in here so I can see the polygons closer to Portage la Prairie. And as you hover your cursor over the different polygons here, you can see there's a polygon number. And for today, our farm is located inside of polygon 851003. So here we go. This is 851003. And for soil data, it doesn't matter where inside this polygon you click, but it's important to click the precise location within the polygon to get more accurate climate data. So depending on where you click within this polygon, you're going to get climate-specific data for that location. So I'm going to right-click to select the polygon and to start downloading daily climate data. So as you click, you'll notice that we got a little prompt saying that we're downloading climate data, and that climate data is daily climate data going back to 1981, and that's downloaded from the NASA website API. So now we have our soil selected, we have our farm location, and we have our climate data. So now we can explore this map screen a little bit more. On the right here, we have location details, which is giving us the eco-district number, the polygon number, and then the precise location. Let me just scroll over here. Okay, so and also on the right side here, we can see we have 3 tabs. So on the soil zones tab, you can see that within this polygon, there are 3 different soil types. And so depending on where your farm's location is located, you can look at these soil types and click and select a soil type that is more suited to your precise location. But by default, Holos is just going to select the first one on the list, and that's black with a fine soil texture. So Holos also supports shelter belts. So if we were going to demo shelter belts, we would also select our hardiness zone. But since this demonstration won't be going to shelter belts, we can just leave this as a 3B selection, indicating which hardiness zone we're in. And finally, if you're not happy for any reason with the NASA climate data, or if you're working offline, in which case Holos can't contact NASA, you're able to click on this tab, click this button, and then you can upload your own custom climate data. So that's helpful in certain situations. All right, so we're going to leave it here. I'm going to pause for about 5 minutes, and this will give you a chance to follow along with Holos on your systems. And then we'll come back after 5 minutes and continue on with the demonstration. And again, if you have questions, please ask. Okay, we'll give it about 1 more minute, and then we'll continue on. Okay, so now that we set our farm's location, We've configured our soil type, and we also imported custom climate data if we wanted to. We're ready to start setting up our farm. So we set up the farm's location. Now we have to tell Holos what is actually on the farm. So I'm going to click next. And then here we'll see something called the component selection screen. So on the left column here, you can see the screen is split up into two columns. On the left here is all the farm's components that you could add to your farm. And then on the right-hand side here is all the components that are currently on your farm. So as you can tell here, with a new farm, we start off with a fresh slate, and there's no components selected. On the left-hand side here, we can see we have component categories. So we have land management, beef production, and dairy cattle, and several other categories that we won't go into. But for our first two components, we're going to add two fields. So I'm going to expand this land management category. And you open this category by expanding this little expander here. And for our first component, it's going to be a wheat field. So I'm going to click on the field and I'm going to drag it to my farm on the right. And then as you can see, depending on what component you added, the screen is going to update the interface with all the necessary inputs that we need to perform the calculations. So our first field is going to be growing wheat and a cover crop of hairy vetch. So I'm going to rename this. I'm going to call it wheat and hairy vetch. Next, we're going to change the area of this field from 1 hectare to 18. And then we're going to leave these two defaults for 1985 and 2026. So that's step one. That's just the basic properties of the field. Now we're going to go to step two and tell Holos what's growing on this field. So by default, the first crop that is added to the field is wheat. So that's good. We want wheat and hairy vetch. So now we have to go to the cover crop drop down and find hairy vetch. Select hairy vetch. And now we set up our species on this field in this particular year, 2026. So now we're going to go down to step 3 and start defining the management for this field. So we're going to update this yield here. By default, this Holos gives us a default of 3,600 kilograms per hectare, but we're going to change this to 3,600 instead. So it's important to note that we just entered the wet weight, but you also have an opportunity to enter the dry weight. And then depending on what the moisture content is, Holos will do the adjustments for you. So we're going to go on to irrigation next, and we're going to change this to 200 millimeters. And there's no pesticide. And we're going to leave the harvest method as cash crop, but you also have options if cash crop isn't what you want. Okay, so that's step 3, the general tab. Now we're going to move on to the fertilizer tab, and we're going to add a fertilizer application to this field. So I'm going to click this button called Add Fertilizer Application. And by default, Holos will suggest a blend of urea, so that's fine for our purposes. We're going to look at this application rate, and we're also going to leave that as a default. If you want to enter more details about your particular fertilizer application, you can go here and click Yes, besides show additional information. And then as you can see, you can enter some advanced or additional information pertinent to your fertilizer application. All right, so that's our first field. We're going to drag and drop another field here to set up our farm. And this time we're going to be adding a grassland. So we're going to change this from field 1. We're going to call it our native grassland. This field is going to be a little bit bigger, so we're going to say it's 100 hectares. And under step 2, we have to change the crop type from wheat to a perennial. So we're going to scroll down to the perennial section, and we're going to select rangeland native. And so when you select a perennial, you'll notice that the the step 3 area changes because now we're dealing with perennial, and sometimes inputs only apply to perennials versus annuals. So that's why you see a sort of a different general tab here. Okay, we're going to say this field isn't irrigated, so we have to change this. And also there's no fertilizer on this field, so we can leave everything else as default. So now we've added 2 fields to our farm. Before we start adding dairy components, we're going to pause here so you can have the opportunity to drag and drop these 2 fields and configure them just as we did. So we'll pause here for about another 5 minutes. Okay, so about 1 more minute, then we'll continue on. Okay, so we'll move on. So we've added 2 fields to our farm. That's the land management component of Holos. But now we can add some animals to our farm. And so adding animal components follows the same procedure as adding fields. You just have to go to the appropriate category. And in this case, that's dairy cattle. So I'm going to expand dairy cattle here. I'm going to drag and drop one dairy component into the My Farm column here. All right, so now we have our dairy cattle component selected. And you'll notice that the layout of the input screen has changed a little bit from the field inputs. These inputs are available for animal components. And so the step 1 has changed a little bit as well. So under step 1 for animal components, we can see here that we have all of our groups. By default, we have 4 groups. We have dairy heifers, dairy lactating, dairy calves, and dairy dry. You have the option to adjust this setting or this setup if you want. You can remove groups by clicking this X icon here, and you can also add groups to your component as well. Okay, so for our next step, we're going to be working with the dairy lactating group. So in this grid here, I'm going to select on the left here, on the far left, until we get this little indicator saying that we have selected this row. And that means that we are now working with the dairy lactating group of animals. And so under step 2, we can see something called management practices, or as is labeled here, stages of production. We want to make sure that we work with the early lactation management period. So we're going to click here and make sure it's selected. And you can always tell a row is selected by this little right-facing indicator here. So a couple things to verify for this management period. We just want to make sure that January 1st, 2025 is set as the start date. And we also want to check that May 31st is set as the end date. And so that all looks good. So here is the number of days for this management period. And now if we go down to step 3, we can start defining management for this particular group of dairy lactating animals during this selected period of time here. All right, so one of the first changes we're going to make is we're going to change the number of animals. So by default, Holos just suggests 20 animals, but we're going to update that to 65. And we're also going to change the diet information for these animals. So we're currently on the General tab. We're going to click on the Diet tab. And here you can see something called System Diets. These are all pre-made diets, but if there's something that you would like to adjust or add to a custom diet or create a custom diet, you can do that by clicking this button here called the Custom Diet Creator button. And so what pops up here is the Custom Diet Creator screen, and we have 3 sections. We have step 1, step 2, and step 3. So under step 1, we're going to click Add Custom Diet, and we're going to rename it. So I'm going to click in this cell here, and we're going to call this Custom Dairy Diet. Okay, so that's step 1. We define a new diet, but currently it's an empty diet, so there's no ingredients in the diet. So we have to go to step 2. And for step 2, we're going to add alfalfa. So let's find alfalfa in the list here. This is a rather large list. You can scroll through and see all the ingredients. If you're looking for a particular ingredient, you can also click the search box and enter the name of the ingredient, and then Holos will search the list for you. But I have alfalfa selected here, so I'm going to click this Add Selected Ingredient to Diet, and then that's going to appear under step 3 here. So the next step is we have to tell Holos what is the composition of this diet when we have these ingredients. So we're going to add 2 ingredients, but for now we're going to say this diet is going to be 50% alfalfa. So I'm going to change that to 50. And for our second ingredient, we're going to add barley grain. So I might as well search for it. And we'll go with this option here, barley grain roll. So I'm going to click on that. And then same procedure, click this button to add it to our diet. And then again, we have to tell Holos what is the composition of all the ingredients. So we're going to say it's a 50-50 alfalfa and barley. And now step 3 tells us that the diet is complete because the sum of all the ingredients, the percentages in diet, sums up to 100%, so we're ready to go. Once you're done configuring your diet, you can click OK. And now we're back at the dairy lactating early lactation management period, and we have our custom diet available. So I'm going to go into the diet drop-down menu. I'm going to select the first one, which is the diet that we just created. Okay, so that's the diet tab. Now we're going to go on to the housing tab. So the housing tab, we're going to select Thai stall slurry. So you have many options here in the drop down, but we're going to go with Thai stall slurry. You're going to select that. And if you want to see additional information on any of these tabs, you can go to this yes, no toggle button, and then you can configure advanced properties and inputs and emission factors for different aspects of the calculations. All right, so we configured our housing. Now we have to configure our manure handling system. And we're going to go to the drop-down tab. And we're going to select liquid slurry with no natural crust. And again, if you want to configure advanced details, you can do so by clicking this button. All right, so now we configured our dairy lactating group. Now we're going to configure our dairy calves. So I'm going to click here under step 1 to select the dairy calves group. And we're going to go to step 2. And as we can see, there's only one management period this time. This is the default. This isn't set in stone, so you can add additional management periods if you want. And you can also remove management periods as needed. So again, we're going to verify the start dates as January 1st, 2025, and the end dates April 1st, 2025. So that all looks fine. Now we're ready to start setting up our management. So we'll go down to step 3. We'll click on the general tab, and we're going to change the number of animals from 20 to 45. And then we're going to go to manure. And we're going to select liquid slurry with no natural crust. And then we'll click on the housing tab. And then we're going to select freestall barn slurry scraping. And now we've configured our calf groups. So the last group that we want to configure here, or sorry, the second to last, is the dairy or the replacement heifers. So we're going to go back here to our step 1, select the dairy heifers group. We're just going to verify that our management period is set up according to the dates that we want. So verify January 1st, 2026 and January 31st, 2026 as the end date. And then we're going to come down and configure our management. So we're going to change the usual here. So we're going to say we have 15 animals instead of 20. Under diets, we're going to select one of the pre-configured system diets. We're not going to use our custom dairy diet. We're going to select high fiber as the diet. And for housing, we're going to go with freestall barn, slurry scraping. And then for our manure handling system, we're going to select liquid slurry with no natural crust. And now we configure our management for the dairy replacement heifers. So the last group we're going to configure is the dairy dry group. So I'm going to go back to step 1, select dairy dry. I'm going to verify that the dates look good. So start date is November 5th, 2025, and the end date goes into next year. So it's going to be January 4th, 2026. Going back to the general tab, I'm going to say we have 30 animals. And for diets, we're going to select legume forage-based diet, which is the default selection. And housing, we're going to stick with freestall barn slurry scraping. And then for our manure handling system, we're going to select liquid slurry with no natural crust. Okay, so that's how you configure an animal component, and in this case we configured a dairy component. The basic setup is you select your animal group first, and then you set up your management periods, your start and end date for each management period, and then for each management period you select the appropriate one, and then you come down to step 3, and then you tell Holos how many animals you have, where they're housed, and how manure is being handled, in addition to the diet. Okay, so I think we'll pause here for about 7 minutes this time so you can add a dairy component to your farm. If you get stuck or if you have questions, feel free to ask. Okay, so about 1 more minute, then we'll continue on. Okay, so we'll continue on. So at this point, we've added 3 components to our farm. We have 2 field components and 1 animal component. At this point, if we wanted, we have a basic setup for our farm so we can continue to see the results. But now that we have animal components, other interesting aspects of the software become available to us. So in addition to synthetic fertilizer that we applied on our wheat field, we now have the opportunity to apply manure to our field because we have our dairy animal components. So that's what we're going to do next. So we're going to make sure we have our wheat and hairy vetch field selected. And then instead of going to the fertilizer tab, we have a dedicated tab for manure application. So I'm going to click that. And I'm going to click this Add Manure Application button. If we go back to our dairy component quickly here, we can see our dairy heifers have a management period that goes from January 1st, 2026 to the end of January in 2026. So we're going to make use of this manure from this particular management period and apply that to a field. So we're going to go back here and we're going to say, so when we're in 2026, so we want to apply manure to this field in the year 2026. So we have to adjust the date first. And we're going to go in January, let's say 14th. And then we're going to say it's livestock manure. So the origin of the manure is livestock. You have the option to select imported. For manure type, we're going to say it's dairy cattle because we have dairy animals on our farm. And for the manure handling system, we're going to select liquid slurry with no natural crust. And then for the application method, we'll select shallow injection. And we're just going to make it a very trivial small amount here just for demonstration purposes. So now, in addition to our synthetic fertilizer, we also have a manure application on this field in 2026. If you want to see the amounts of manure that are available for field applications, again, you can go up here and choose to show additional information. And then Holos is going to show you the amount of this particular type of manure. So our handling system was liquid slurry with no natural crust. And so this dial or this gauge here is telling you how much manure is available for this particular type and how much you can apply to the field. And if you scroll down, you can see the composition of the manure, so the total nitrogen, the total carbon, and then the total volume of the manure. All right, so we'll pause here for just a few minutes so you can add this manure application to your wheat fields. So I can see there's a question in chat here regarding what this information is telling the user. So when you click show additional information on the in the center here, you'll see this additional information. These dials are showing you information for all the manure tanks that are handled or that are stored in the farm here. So since we have a dairy component, we have many different manure handling systems, and so we're going to have a different tank for each manure handling system. So for this particular manure application, we had the manure handling system set as liquid slurry with no natural crust. So what this gauge is saying is for this particular type of storage, for this storage tank, this is how much manure nitrogen is remaining in kilograms N. And so when you're making a manure application, the gauge gets reduced, obviously, depending on the amount of the application. So how many kilograms per hectare if you're entering amounts of manure, but you can also enter amounts of nitrogen. And so Holos will do calculations based on the field size, which is 18 hectares. And that will do some math based on the application rate, and that's going to deduct from your available amounts shown in these dials and also in these values here. I hope I answered your question there. Was that a good reply, Roland? Okay, perfect. Okay, so now we're at the stage where we defined 3 components for our farm. We told Holos where our farm is located. We made some management adjustments. We applied a manure application to one of our fields. We applied some synthetic fertilizer. We told Holos what kind of diets our animals are consuming. So at this point, we're basically set up for our calculations next. But before that, there's one more screen or a couple more screens that we can see before we get to the results. So I'm going to click next. What we see here is called the timeline screen. So here on the bottom half of the screen here, we can see we have 2 horizontal bars, and each bar indicates fields on our farm. So we have 2 fields on our farm. So we have 2 bars, one for the native grassland and one for our wheat and hairy veg field. Just quickly going back, if we recall when we added our first field here, we had these 2 values here, 1985 and 2026, that we just ignored. But those values come into consideration here on the timeline. So now Holos is going to back populate the data that we entered in the previous screen back in time to 1985. So in the case of our native grassland field, Holos is going to say, okay, this field was a native grassland from 1985 to 2026. And similarly for our wheat and hairy veg, Holos is going to say this field was growing wheat and hairy veg as a cover crop starting in 1985 and going to 2026. So that's nice. If you don't want to change anything, you can just click next and you go on to the next screen. But if you want to fine tune your field's history, this is where you can add historical and future or projected management practices. So for this demo, I'm going to show how to add a historical management practice. So the first step is to click on the field that you want to edit or change. So there's 2 ways you can do that. You can click it in the visual area here, or you can go to step 1 and then select the appropriate row in the grid here. So again, I'm going to select wheat and hairy veg. So you have 2 options here to edit your management. You can add something that happens before 1985, or you can add something that happens after 2026. And that something is like a management change. So you can grow other crops, you can grow rotations. So for this demonstration, we're going to add a historical production system. So I'm going to click this button here. Excuse me. And now we'll see that we have 2 sections on this field here. The first is our is our new historical practice, which is wheat and hairy veg still by default, but it goes from 1985 to 1989, and then again we have our original setup, which is wheat and hairy veg. So I'm going to click this because I'm going to make some changes. And instead of starting in 1985 and going to 1989, I'm going to say it went to, let's say 1995. So as you can see here, we adjusted the end year for this historical practice. And so that pushed forward our original setup. So now we can change the year, the start year and the end year, but we can also change the crop being grown. So we're going to do that next. So we're going to click on this, and we're going to go to Edit Selected. And again, on this screen here, you can set up all your management, and it's going to apply just for this 1985 to 1995 period of time. So instead of continuous wheat, let's just say we had continuous barley instead. You can also change the yield for these years. So from 1985 to 1995, you can say we had an annual yield of 4,000. We won't make any other changes. We'll just click OK to set everything. And now, as you can see, our original field was growing wheat and hairy veg, but now we have a historical practice going from 1985 to 1995 where we're growing barley. This title here, where you're saying wheat and hairy veg, that's just the name of the field. But what's actually growing here from this period of time now is barley. And then we switch into our original setup, which is wheat. Similarly, you can add future or projected management practices, so you can see what management changes, how they will affect future yield and future soil carbon, not future yield, but future soil carbon changes. Okay, so we're going to pause here for about 4 or 5 minutes so you can make the adjustments on this field and add historical management practice. Okay, so now we'll move on. So we're finished setting up our historical management practice. We're going to click next. And now we're going to go to something called the detail screen. So this detail screen, this is optional. If you don't want to fill in any information, you can just click next and then you'll go to the results. But this screen is sort of a last chance to fine tune your management practices. So what we're going to do here is we're going to find our wheat field and we're going to adjust the crop yield or harvest for one particular year. I'm going to show you how to do that next. So first of all, we're going to filter this column here. So we can see that we have our two fields, which is native grassland and wheat and hairy vetch. But we just want to adjust the yields or the harvest for wheat and hairy vetch. So I'm going to go to the filter and I'm going to select this and click filter. I'm going to close it. And now we can see that we just have our wheat and hairy vetch displayed in this grid here. One other adjustment I'm going to make here is I'm going to add an additional column. So I'm going to expand this sidebar here. And I'm going to find above ground carbon input and choose to show that as a column. So here it is here. I'm going to check it. I'm going to close this. And now for each year, we can see the above ground carbon input. So further, we're going to refine it a little bit more so we filter out just the wheat crop and not the cover crop aspect. I know they're intermixed, but we can filter them out just based on the main crop. So I'm going to select wheat. And so as a hypothetical, we'll just say in 2005 is when we had a really good harvest. So we're going to choose 2005 as the year to adjust the harvest. So again, I'm going to filter just so I can see 2005. And by default, Holos doesn't give you a default suggested yield, but these are just suggestions. They're not necessarily accurate. So if you have measured actual yields, you can change that value here. And that's what I'm going to do here. So let's just say our harvest in that year was slightly better, and we'll change it to 2,400 kilograms. And then I'm not sure if you noticed or not, but as you increase the yield, the above ground carbon input calculation increases accordingly as well. So now that we made that change, we can clear our all the filters here. So I'm just going to unselect these checkboxes. And then again, if we scroll down in 2005, we can see our adjusted yields. So that's the detail screen. So basically, it just gives you a final chance to edit any yields or harvest data. If you're not happy with these default harvests, you have the option to import an Excel file. So if you go here beside the yield assignment method, we can select custom yield, or we can select input file, and that's going to give you a chance to, first of all, you have to format the input file according to the documentation, but once you have it formatted, you can import that into Holos, and then it's going to reassign all your custom values to each year for all of your fields. So that's the detail screen. So again, we'll pause here for just about 3 minutes, and then we'll continue on to the final screen. Okay, so moving on. So at this point, we set up our farm. We've added components to our farm. We went to the timeline screen and we made some slight adjustments. We said instead of having a continuous wheat field, we had a historical management practice before we started growing continuous wheat. And then lastly, we went to the details screen and we made some minor fine-tuning edits for the harvest data. So at this point, we're ready to go in and see the results. So the last thing that we have to do is just click next. And now we're brought to the Holos results screen. So if you look along the top here, you can see all of the reports here are organized in a tab format. So we have our most interesting report, which is the detailed emissions report. We have some bar charts, 2 bar charts. We have a pie chart, economics, manure management, feed estimates, and then we also have a multi-year carbon modeling report. So I'm going to start with the detailed emissions report and just give you a general overview of what information you can see here. The first thing to note is that this report is sensitive to the year that you're interested in here. So if you go up here, you can select different report years. And since we had management periods for our dairy animals that span multiple years, you're going to see a drop down with multiple years to select. But we'll just keep it set at 2026 for now. Some other adjustments you can make before we actually look at the data is the units of measurement. So you can choose kilograms of CO2 equivalents, or you can choose raw greenhouse gases, so kilograms of GHGs. This entire report can also be exported to Excel. So if you want to manipulate the data a little bit, or if you want to post-process in some kind of scripting language like Python or R, you can click this button and then Holos is going to export the entire table that we see here into Excel. All right, so going to the actual report here, you can see that there's a number of columns starting in this table. So the first column is the farm, and this is the farm name. So we're only seeing one farm here, but if you have multiple farms in your system, you have the opportunity to compare and contrast farms. So if you have multiple farms loaded on this results screen, you'll see the farm name in this first cell here, so you can compare 2 farms against each other. Next, we have the component name, and so everything in Holos is a component. So in the crop section, we had 2 fields, and that's what we're seeing here. So the component name is wheat and hairy veg for one field, and then native grassland for our other field. And then we had 1 dairy cattle component, and here that animal component is broken up into heifers and dairy dry. And again, the reason you're only seeing 2 animal groups, even though we had 4 for the component, is because these animals were only managed in 2026. If we go back to 2025, we'll see the other animals from the other management periods. All right, so the first emission column that we can see here is enteric methane. This doesn't apply to crops, obviously, but if we scroll down to our animals, we can see the values here. Next column is the manure methane. And again, this is in kilograms of CO2 equivalents. We can see the values for the heifers and the dairy dry. And then for direct N2O, we can see here that we have values for the field. For indirect N2O, we have values for the field. Farm energy, this is another important and interesting calculation. So this is the energy required for machinery operations. And then upstream CO2, this is the energy associated with at the gate emissions or fertilizer production. So we have our subtotals here. You can expand this report from an annual basis to a monthly basis. So if I click that, Holos is going to do some calculations, and it's going to show a breakdown month by month, again for 2026. So you can get a more detailed look at how your emissions are spread out over the months for that particular year. I think I'll show you one more report here, and that's the multi-year carbon modeling report. So we had 2 fields grown. We had wheat and hairy veg, and we had our rangeland. So we can see here on this report how the soil organic carbon changes over time, starting in 1985 and going to 2025. By default, you're just going to see a line chart, which can be helpful for summaries, but if you want more detailed information, you can change the report format, and we do that by clicking this grid button here. And so as you can see here, there's lots of detail for all of the fields on the farm, and again, it's broken down by year. So here we can see our historical management practice, which went from 1985 to 1995 when we were growing continuous barley. We can see some calculations here. If we scroll over to the right, though, we can actually see the soil carbon estimates for the field. If we scroll to the next column, we can see the change from year to year in the soil carbon. And if we keep scrolling to the right here, we can see some N2O emissions for the fields. It's important to note that this report that we're seeing here, this just applies to the fields. So the animals are reported in other reports, but what we're looking at here is basically the soil carbon and the N2O as it relates to the fields on our farm. One last thing to note that we can do here is we can also export this data. So if we click this button, we can export the data. Sure. So on this report here, the way you export, got a question in chat here asking how you export the data. So for this multi-year carbon modeling report, what we're seeing here is a grid here, and you can export this grid and all the data by clicking this button here. So if I click that, it's going to ask you where you want to save the report. You can export it, you can give it a name, and it's just a basic CSV file. You can convert it to an Excel SX spreadsheet with more functionality, but right now it's just a basic row and column type of format. So you can save that, and then you can, like I said before, you can either post-process with a script, or you can create your own charts by importing it into Excel and selecting and slicing and dicing your data, and then creating custom reports that way, or custom charts. For the detailed emissions reports, the process is similar. You just click this export to Excel, and by default, you'll get this detailed emissions report name, and this is an actual more fully featured XLSX sheet, so different than a CSV sheet. But that is the results screen. So once you set up your farm, you'll come to the final screen, which is the results. And as I mentioned, we have all these various tabs here, reporting on your emissions. If you want to export the data, that option is available to you. But I think we can stop there and open it up to questions. I should also mention that before we move on to the next part, we should probably have a bio break, so we'll pause for about 10 minutes after our discussion here, after our question and answer period. All right, and I'll just wait here for Roland to pass along the questions to me. All right, I don't see any questions coming in. I'll wait for a couple more minutes here, but if there are no questions, then we can take a 10-minute bio break, like I said, and then I'll get into the next part of the presentation, which is a discussion on the next version of Holos. seeing a question in chat here that says, can you clarify the units for manure application, kilograms per hectare? Is that kilograms of manure per hectare or kilograms of N per hectare? That's a good question. So I'm going to scroll back here to our component selection screen. And our manure application was made on the wheat and hairy vetch field. And so I'm going to go and click on the manure tab so we can see the inputs related to manure applications. So for this demo, what I did is I entered 1,000 kilograms or 1,000 into this input box here. So that means that I entered 1,000 kilograms per hectare of manure. So that's just the volume measurement. You can also alternatively enter the amount of nitrogen applied per hectare. So this was volume per hectare that I applied, but you can change the application so that it reflects the amount of nitrogen you applied to per hectare. And that's what you would do here. You would select this input box, and then you would make your adjustment there. But it's important to note that this is kilograms of volume, so just the raw volume, and then this is the actual N content based on this fraction of nitrogen in manure here and the amount of manure or the volume that you've applied. So you can sort of do one or the other. I hope that answered your question. So the next question is, can you give a brief description of how energy is calculated? Can you change practices and have the energy change, number of tillage passes, etc.? Another good question. So Holos has a very detailed algorithm document, and that would be the first place to go to if you have specific questions about how Holos calculates energy as it relates to either animals or cropping operations. If I go back to the general tab here, there are some things that affect the amount of energy or the energy calculations or the energy emissions. And one of those would be the number of pesticide passes. And obviously there's other constants that you can adjust to. So the calculations take into account the emission factors, and those one energy emission factor is the fuel energy here and herbicide energy. So when all is said and done, when Holos is doing its calculations, it takes these values and then calculates the emissions. There's some more inputs that you can adjust for energy, and if you go to the settings energy menu here, you'll see all of the emission factors as it relates to energy emissions. So you can adjust diesel fuel production, for example. You can adjust for dairy animals. For animal operations, you can adjust the amount of electricity or the emission factors for housing. And then for actual manure applications that are applied by tractor, you can adjust the amounts or the emission factors for those calculations. So that's where I would go to get a better understanding of how Holos calculates and what emission factors are used. Okay, next question. Did we modify items for mid and late lactation periods? If not, how do we see erroneous date in the entry default manure storage? Okay, so I'm going to go back. I'm going to close this window. I'm going to click on the dairy component. And so I think this question relates to how a user checks to see if they have bad data or if they entered bad data. One way you can do that is on the component selection screen. You would go to all of your animal groups, and this is a good practice to do in any case, is just to verify what inputs you actually entered, because sometimes when you're looking at the results, one particular emission value might be a little bit higher than you're expecting, and typically that indicates some kind of user entry or user data entry error. So what I would do is I would go back to our dairy component. I would go through each animal group, And then I would select each management practice for each animal group. And then I would verify, in this case, it sounds like it's a manure-related question. I would go to the manure tab and make sure that the handling system is correct. If you know what the emission factors are, or if you want adjustments to be made, or if you're working with an older farm that might have incorrect data, this is another place that you can verify the values to ensure that your calculations are correct. But again, I would go through each animal group. I would select each management period. So as you can see, there are differences here, and this is just because I didn't go through each management period in the training. We only adjusted the early lactation management period. We did not change anything in the mid lactation or late lactation. So if we make a note here of the number of animals in early lactation, it says 65, but if we go to mid lactation, it's the default of 20. So that could be, I hope that is what you're getting at. It's just a difference of the number of animals, and that's going to throw off the calculation since we have a smaller number of animals for that mid lactation and late lactation period. Roland, can you let me know if we're good to go with our break or if there's any remaining questions? All right, so that's all questions. So I think we'll take a 10-minute bio break here, and then we'll return with a demonstration and a presentation on the next version of Holos. Thank you. Oh, I'm muted. So hello, everybody, and welcome back. For those who might be joining, my name is Aaron McPherson. I'm the software developer for the Holos project at Agriculture and Agri-Food Canada. And for this presentation, I'll be giving sort of a sneak peek into the next version of Holos. So let me just start by acknowledging the Holos development team. We have Roland Krobel, who is our project lead, Sarah Pogue, who is the scientific model developer, Pam Mantle, who is our data technician, and Wyatt Bristow, who is an undergraduate co-op student at the University of Lethbridge, who has been working with me on Holos. Today, I'll be giving a preview of what's coming up in the next iteration of Holos. I'd like to emphasize up front that the next iteration is still in development. It's not available just right now for public use, but the planned release is for early summer 2026. So the goal of this presentation is to show you the direction that we're heading and the improvements you can look forward to. Version 4 remains the current production version, so please continue using version 4 for all of your work until we release the updated version. All right, so here's a quick overview of what we'll cover in the next 20 minutes or so. We'll start with a brief refresher on what Holos does. Then we'll look at what version 4 can do and where it has its limitations. And then from there, we'll walk through the main improvements in the redesign. And that's cross-platform supports, a modernized interface, the same greenhouse gas calculations, I want to stress that, and also the user interface becoming open source. And then we'll wrap up the talk about giving you some insight on what you can expect once the redesign is eventually released. And then we'll open the floor for questions. But before questions, there'll also be a live demo. All right, so for those of you who may be new to Holos, let me give you a quick refresher. Holos is a whole farm model developed by Agriculture and Agri-Food Canada. It estimates greenhouse gases, including carbon dioxide, methane, and nitrous oxide. And this is based on the information you enter into Holos about your farm. The main purpose is to let you test different management scenarios and see how they affect your farm's carbon footprint. For example, you might compare different tillage practices, or feeding strategies with your animals, or land management approaches. Holos covers all the major farm components, so livestock, land management, and shelter belts. It's available at no cost and supports both English and French, and is used by farmers, researchers, and consultants across Canada. So let's take a moment to acknowledge what version 4 does well before we talk about changes. On the strength side, version 4 provides comprehensive greenhouse gas calculations from all major farm components. It has detailed livestock models, soil carbon tracking using IPCC Tier 2 and ICBM models, and integrates real-time climate data for accurate regional estimates. It also includes training guides for each component type. However, there are some significant limitations. The biggest one for many of you is that version 4 only runs on Windows. So if you're a Mac or Linux user, you simply can't run Holos at this time. It's also built on older software technology, something called .NET Framework, which limits future development options and support. The graphical interface code was also not open source, which limited community involvement and transparency. So these limitations are exactly what motivated us to pursue a redesign. All right, so there are 4 main reasons why we're pursuing this redesign. First, we want to reach more users. Many researchers and farmers use Mac or Linux, so removing the Windows-only barrier was a top priority and is a top priority. Second, we're moving to modern software technology, specifically something called .NET 9, which is the latest platform from Microsoft. This provides better performance and ensures long-term support from Microsoft. Third, the core science and algorithms have already been open source on GitHub. What's new in the redesign is that the user interface is now open source as well. So previously, the graphical interface relied on proprietary third-party controls, which prevented us from releasing the code, which prevented us from releasing the user interface. So by switching to open source components, the entire application is now fully open source, or will be open source. So talking a little bit more about cross-platform support. So the redesign is built using a framework called Avalonia. So without getting into the technical details, the key takeaway is that the same Holos application will run natively on Windows, Mac, and Linux. And what this means is Holos will look the same whether you're using Windows or Linux or Mac computers. For Windows users, nothing changes in terms of functionality. You'll continue to use Holos just as you do today, but with the improved interface features that we'll talk about later. For Mac users, Holos will run natively on Mac without needing virtual machines or something called Boot Camp. For Linux users, especially those in research environments, you'll be able to run Holos directly on your workstations or even in server environments. Again, stressing that the calculations are exactly the same across all platforms. The science doesn't change. It's only the operating system that you're running on. So beyond cross-platform support, we've also invested in improving the day-to-day user experience. The interface has been redesigned with a modern look and feel. It's cleaner, more responsive, and will feel native whether you're on Windows, Mac, or Linux. The charting library used for the reports has been upgraded to something called Live Charts, which is providing more interactive graphs for visualizing emission results. The redesign adds new options for selecting farm locations in addition to clicking on the map, as you did in version 4. Users can now enter latitude and longitude coordinates or type in a street or road address to set their farm's location. On the performance side, with the modern software technology, .NET 9, this brings noticeable improvements. The application starts up faster, it runs the calculations more efficiently, and handles larger farm files with better memory management. And finally, the navigation has been improved to make it easier to move between farm components, view results, and manage different scenarios. So now we'll talk about the greenhouse gas calculations, the science behind the tool. I want to be very clear on this point that the science has not changed in the redesign. All the models, the methodologies, and the emission factors are exactly the same as they are in version 4. This is a technology and platform upgrade, not a scientific update. So on the left, you'll see the core capabilities that have been in Holos and continue to be in the redesign. All livestock types, IPCC Tier 2 and ICBM soil carbon modeling, enteric and manure methane, nitrous oxide, shelter belts, NASA climate data. These are all preserved in the next iteration. On the right, you'll see additional capabilities that are also carried forward. The AD system, diet formulation, economics, custom climate files, province-specific defaults, and map-based farm management. All of these continue to work exactly as they do today. So the key message is the science is identical between version 4 and the redesign. Nothing about the calculations is changing. All right, so this slide covers how we approach building the redesigned user interface. With a large amount of interface code to write, we looked at ways to work more efficiently. And so AI tools have helped us with some of that work. I want to be clear about where it was used and where it was not used. So AI was used only for the tedious parts of software development. So things such as building user interface code, creating user interface layout files, and repetitive user interface scaffolding. So these are time-consuming but straightforward tasks that don't require scientific judgment. So AI was not used for the science. The greenhouse gas calculations, the models, the methodologies, those are all created and developed by our science team. That has not changed at all. The software development role on this team is focused on implementing those algorithms reliably and making sure the software performs well. So sort of a basic analogy here, think of a robot on an assembly line. The robot welds the panels together, but an engineer designs the car. So AI code tools play a similar role in our development process. They handle the repetitive work of building the interface while our team designs the science. All right, so excuse me. Some of you may already be familiar with the command line interface from version 4. It has been a part of Holos for some time, and the redesign continues to include it unchanged. The command line interface lets you run Holos without the graphical user interface or the GUI, and this is useful for batch processing rather than opening the application manually for each farm. You can prepare your input files, run a single command, and collect your results automatically. The CLI integrates with other tools, so you can call the CLI from scripting languages like Python or R, and you can get your data output from the CLI and then include it in your data analysis. And because the command line interface does not require graphical display, it works on remote servers and cloud environments for large-scale studies. So the Holos core science and algorithms have been available as open source on GitHub. One of the changes in the redesign is that the user interface is now open source as well. And this is under the GPL license version 3. So previously, the graphical user interface relied on proprietary third-party controls that could not be released publicly, so we couldn't include them in GitHub. But by switching to open source components, the entire application is now fully open source. So what does this mean? 1, transparency. The source code and every algorithm behind the calculations are now publicly available for verification. 2, community contributions. Scientists and developers can suggest improvements, report issues, and contribute to the code base. Holos will always remain free and under the open source license. And finally, the open source model supports independent review. So other research groups can independently review the methodology, validate the calculations, and cite the software in their publications with full transparency. So what should you expect when the redesign is eventually released? First, and most importantly, the next iteration is still in development, so it's not ready for public use just yet. The planned release is early summer of this year, So please continue using version 4 up until that time. When the redesign is released, the overall workflow will be very familiar. You'll still create a farm, add your components, enter your data, and view your results. The core workflow isn't changing, just the technology behind it. We are also working to ensure that your existing version 4 farm files can be imported into the new system so you won't lose your previous work. This is a one-way compatibility. Farm files created in the redesign will not be able to be read in version 4. So it's a one-way progression from version 4 import into version 5. Updated documentation and training guides will be prepared before the release, covering each farm component with step-by-step instructions. And those interested in early testing before the public release can reach out to us through the usual channels, and I'll include some contact information on the final slide. Okay, so now I'd like to show you a quick video demonstration created by Wyatt Bristow, who is an undergraduate computer science co-op student at the University of Lethbridge, who has been working on the redesign. Wyatt has created a demonstration of the updated map feature, so the updated map screen. So in addition, like I mentioned before, in addition to clicking on the map to select the farm's location, you can also enter the latitude and longitude or a street address. So we'll start Wyatt's demo. Please start that video. Thank you.
Hello everyone, my name is Wyatt Bristow. I'm a part-time C# software developer student working with the Holos team while I complete my final semester of studies in computer science at the University of Lethbridge. Unfortunately, I can't be attending live today due to prior commitments with class, so hopefully this video will suffice. I'm just going to be demoing the new farm location selection feature that will be in Holos 5. This is what the screen will look like after the user inputs their new farm name for the save file. It will load up this screen with a map, and on the left side, in the top left, they'll see that they have to select their province that the farm is located in. So they'll left click this drop down that reads select your province, and let's say their farm is located in Alberta. So they'll select Alberta, which will then navigate the map to focus on Alberta and load a bunch of polygons within. So then the user would move on to step 2, which is to enter their location. And in step 2, they have 3 options. By default, right-clicking their farm location on the map is what's initially selected. So with this one selected, the user would zoom in, and let's say that they know their farm is located east of Red Deer. So they'd zoom in, and let's say they know it's here. So they just right-click, and that sets the location of their farm in Holos. And then they would move on to step 3. But let's say they don't know the exact location of their farm on a map. They know the latitude and longitude of their farm. So they can select this option, which would be empty if we didn't right-click on the map earlier. So with this option selected, we can input the exact coordinates of our farm. And with this done, we can just simply click the Find Coordinate button, and Holos' map will navigate to the coordinates input. And then this will be the new location of our farm for this file. But let's say for a user that doesn't know the exact location of the farm on the map, or they don't know the exact latitude and longitude, we've introduced a third feature called Road Search. And with this feature, a user may know the road name that their farm is located near. So they can input the name of the road that their farm is located near, the municipality, which in this case is Oyen, and then the postal code. And with these fields entered, the Get Coordinates button will activate. And then when we click this, Holos will find this road, and then once found, we get an approximate location of our farm. And then let's say we know that our farm is located on the intersection of these 2 roads. Like the first step, we just need to right click, and Holos will set the exact location of our farm. And now with step 2 complete, we just move on to step 3, which is just to click this Get Soil Data button, which will bring us to the next screen. So yeah, that is the farm location selection screen that we've built for Holos version 5. Thank you.
Great. So as you can see, the next version of Holos will have a different map interface, and as Wyatt demonstrated, it's fairly intuitive and makes it easier to locate your farm's locations. All right, so now I'm going to go into the live demo and show you what the next iteration of Holos looks like. And it's going to be mainly composed of 2 parts. So I'm going to start by showing you the component selection screen, and then I'm going to go into 2 of the components. And those 2 components are the dairy component, and the second component is the crop rotation component. So I'm going to stop PowerPoint here. And I'm going to bring up the next version of Holos. You just give me 1 second. I'm going to bring up my speaking notes here. Okay, great. So this is the next iteration. So when we finally release the next version, this is what you'll be seeing, or something very close to it. Since this is still in active development, we might still tweak a few things here and there. But when you start Holos, you'll select your farm's location just like in version 4. And then you'll come to something called the component selection screen, again, just like in version 4. But as you can see here, this is the next version of the component selection screen. And it differs just slightly compared to version 4. The first thing you'll notice is that the options or the components that you can select are laid out here. And these are the categories that you can select from. So right now on the left, there's no more list of available components. It's just the components that you have on your farm. And if you want to change, add, or remove components, you'll have to click this button here called Edit Components. And so once you click this button, Holos is going to give you all the components that you can add to your farm. So if we go to something called the land management component, we can click here. And then we can see we have 3 options here. And those 3 options are a field component, a rotation component, and a shelter belt component. And so the way you add these components to your farm is to simply click this Add to Farm button. And you'll notice down here, you get a little notification saying that the system has added this field to your farm. If you want to go back, if you want to select a different component category, you can go here, click this button, and then you can add a dairy component. So I'm going to add a dairy component here. Again, the system is going to notify that a component has been added to your farm. And then once you're finished selecting your components, you click this button here called Finish Selecting Components. And then we have our farm set up with our components. Okay, and so now, similar to version 4, you have to click on a component to activate it. So I'm going to click on this dairy cattle number 2 component. And then we can see we have something called step 1, step 2, and then down here, step 3. So it's very similar to Holos version 4, but the layout is a little bit different. So starting with step 1, we always start with 4 categories or groups of animals. So we have calves, heifers, lactating, and dry. And so the way you start changing or interacting with the system for a particular group is to select these cards, they're called here in the interface. And when you select a card, you'll be changing the management for those particular animals. So we scroll down here, we can see step 2 and step 3, but this is all information related to the heifer group here. One new addition to the interface here is a new interactivity aspect. So if I click Show Advanced Options, we'll see here we have a new life cycle diagram, and this is just as it relates to dairy animals. So the idea being that Holos is used in schools and universities, and sometimes students aren't necessarily dairy experts or experts in any aspect of the Holos software or the life cycle of the various animal groups. So the idea here was that we would show them some kind of interactive life cycle chart that they can click on and interact with. And once they click on a node here, it's going to give some more detailed information about that particular life cycle aspect. All right, so I'm going to hide that. And now we'll go down and we'll see some of the more advanced options here. So step 2, we have the heifer group selected. We have the option here to define more than one group, so similar to version 4. But by default, we start with a single animal group. So we start with a single group of heifers. In this case, we have 50 animals that are staying in this stage for 608 days. But we can change these values here. And we can also say that we have multiple groups of heifers, not just a single group. And we do that by clicking this box here. And so if we want to say we have 2 groups under management, 2 groups of heifers, we would add 2 groups. And we would say there's 100 animals here and 100 animals here. So again, if you've been using Holos version 4 for a long time, this layout will be similar. We didn't want to make too many drastic changes, but we also want to update the interface a little bit. Step 3 isn't complete yet, but it's going to work similarly to the way version 4 did. We have different tabs for housing, for the manure management, and for the diet. All right, so that's the brief introduction into the new dairy component. And now I'm going to show you the crop rotation component. Okay, again, so if you've worked with version 4, this interface will look similar to the version 4 crop rotation component, but it differs slightly. The first step is similar to version 4. We have to tell Holos when our crop rotation started. So let's say it started in 2021. And then we also have to say how many fields are in this rotation. So I'm going to say there's 2 fields. And all fields have the same area. So I'm going to say it's 100 hectares. So that's step 1 out of the way. So the next step is to define the crops or the crop sequence in your rotation. And that's what we do in step 2. So under step 2, we're going to click this button called Add Crop. And you can see here we're starting in 2021. So Holos is asking us, what did we grow in 2021? I'm just going to leave it as wheat. But we're going to make the rotation a little bit more interesting. So we're going to add another crop. And we're going to choose, let's say, flax. Let's actually add one more and we'll have a 3-crop rotation. And we'll go and choose chickpeas. So these are the 3 crops that define our rotation, and these are the 3 crops that will be rotated across our 2 fields here. So if we scroll down to step 3 now, this is something new. It's similar to the version 4 timeline screen, but what you're seeing here is the 2 fields with the crops rotated over the fields. So if I click on wheat, I can see here in my 2 fields, which is field 1 and field 2, when this wheat crop will show up on that field as the rotation has been defined. In the same way, I can click flax. I can see when that crop is grown across the 2 fields and in what years. And then the same thing with chickpeas. So this is just a visual aid to help the user define the rotation and then verify it's actually what they want to set up. So that's step 3. Now we have to define the management. We have to define a harvest, irrigation, and all those sort of things. Excuse me. And so the way we do that is we go to one of our fields. We can select either field 1 or field 2, and then we're going to click on one of these cards here. So let's say we want to define the management for wheat in 2021 for field 1. I click on wheat, and then the window scrolls down, and now we're at step 4. We start defining our harvest information for wheat in 2021 in field 1. So now I can change the yield to 2,000 kilograms per hectare. And then you would do something similar. You would define your management for wheat in 2023 for field 2, and then so on and so forth for other crops. But there's a new helper feature in the next version of Holos, and that is something called copy to similar crops. So it would be very tedious if the user had to select each individual crop card here and then go and manually change all the details, all the management information for each year. So with that in mind, we did something called copy to similar crops. So if I select wheat here and I click this button, you'll notice that Holos has selected all the wheat crops in this field here. And so what that means is the management that I change in step 4, not only is it going to apply to 2021, but it also applies to 2024. So if I change the yield to 150 just as a test value, I can click here and the yield is 150. Flax, we didn't change, so it's still 1,000. Chickpeas, still 1,000. But wheat, it should be 150, and we can see that it is 150. And so it would be similar with the other properties and the other management values that you edit. With this feature enabled, you can simplify the copying of data across the crops in a particular field. All right, so that's what I wanted to demonstrate today. I want to show you the new component selection screen. I want to show you the dairy cattle component. And I also wanted to show the crop rotation component. One last thing to note is that the color scheme of the whole application has changed to something called GC Design. So if you've ever visited the federal government website, you'll notice that most of the colors are this blue type of color. And so we've taken that styling aspect and put it into Holos. So this is something that's going to change as well. The whole visual look is going to be a little bit different. Okay, so now I'm going to move on to the slides here and finish up my presentation, and then we'll have some questions. We'll have some time for questions. Okay, so that's it. If you scan this QR code on your phone, this will take you to the Holos GitHub. So this is the place where you can see all the source code. You can see the algorithm document. There's a discussion area where you can ask us questions on the Holos team. If you would like to be notified when we eventually do release this version of Holos, you can send us an email to holos@agr.gc.ca, and then we'll put you on our internal Holos mailing list, and we'll announce when the next version is ready to download. So that's the end of my presentation, the entire presentation. So I'd like to thank you and open it up to questions now. I'm all finished, Roland. So I'm just waiting for questions here. So here's a question. Is it possible for the user to enter farm information in imperial units? Yes. For several reasons, imperial units of measurement in version 4 weren't fully functional. This has been fixed in the next version. So the next version of Holos, you'll be able to switch your units of measurement to imperial, and that means you'll be able to enter your information in imperial units and also view the results in either metric or imperial. Roland, if you could just let me know when there's no more questions and when it would be a good idea to just end the presentation here, I can just wrap up.
Hey, Aaron. Yeah. So one more question from Fisayo. Would the output result be the same with version 4?
So the data will be the same. The calculations are the same as I mentioned. So the outputs, pardon me, will be the same. I'm just, excuse me. I'm just not sure how the format of the reports will look. So it's probably going to be a combination of what we had in version 4, where we had grids and tables, but there's also going to be a more simplified results reports. So it's just going to be text-based. There's going to be no charts, no complicated grids, and then the user is going to be able to change between a simplified report and a more detailed advanced report. We'll try and keep as much information that was presented to the user in the results from version 4. There's a lot of information, a lot of data points to output. So we'll try and keep as much information from version 4 in the next version as possible. I don't think we're going to stop showing any of the major calculations, but they might just be presented in a different way.
Okay, I have to be cognizant of the fact that I'm watching basically our like broadcasting as well as like the live stream. So they are a bit behind, but it may be that they're further behind than not as far behind as I am, because I'm streaming both things at the same time. So I'm waiting to see whether there's more questions coming. But question for you, Aaron, in the meantime, there was a question earlier, how hard is it to add in another language to Holos? And I assume this meant like another spoken language. We already have English and French, but let's say, just for the sake of example, somebody asked for a Spanish version. How much time would that take? How complicated would that get?
So Holos and the underlying software platform technology, they actually make it quite easy to add additional languages. So as Roland mentioned, we have English and French. The way the system is set up, the internals are set up, is that as long as you have somebody that translates all the text that displays in the screen, so wherever you see English text in the screen, as long as somebody is available to make those translations from English to Spanish to Italian to whatever, as long as there's somebody to do that work, adding additional languages is very simple. It's not zero effort, obviously, but it's not as complicated as one might think.
Okay, on my broadcast, I just see us going live, so I don't know how far we're behind. Other question then for you, assuming that the question may have been with respect to another programming language, how hard would that be and how much time would it take?
That's a good question. And I know there's lots of people interested in adopting the Holos model, but maybe they're not interested in using the programming language that I chose or that we chose as a team, which is C# and .NET. So the question really depends on how much of the system do you want to implement in a different language. Let's say it's Python, for example. If you want to take Holos and build a Python version, your options are to translate the source code into Python just for the calculations. So in that situation, you would write the core calculations in Python and you would interact with the systems through some kind of command line interface. So that is possible. But if you want to totally port, and port is the word that they use to transfer a software system to another language, if you want to port it to something like Python, then the interface would obviously look different because it's written in Python. In terms of effort it would take, that's another question that would require some planning and some thoughts. But I don't think it would be that complicated if you're familiar with Python, or if you're more familiar with your language of choice. It just depends. Do you want to build just the calculations and then interact with the system through the command line, or do you want to build a complete rewrite of Holos that includes a new interface? And that will depend on your access to resources, programming resources.
Okay, there is a new question in chat. In Holos 4, I cannot seem to rename the custom ingredient in the custom diet creator anymore. Is it possible to make that function available again?
So I'll have to look at exactly what's happening, but from what I recall, there was the ability to create custom diets and rename those diets, but it may not have been the case to rename custom ingredients. This is another good point to bring up. Here at Lethbridge, there's only one software developer, and that's me. And so we sort of had to make a decision in terms of adding new features and functionality. Bugs are a different story, but adding new features and functionality to version 4, we sort of decided that we would stop devoting effort to making new features for version 4 and work on version 5 so that people with Mac systems can start using Holos. That being said, if anybody finds bugs in the calculations or true bugs in interface, we will always go back and fix those. But as far as reintroducing features that we may have took out for different reasons previously, I would say that's the next thing to do is just to wait for the next version where we could add these additional features into the diet formulator, where you can rename custom ingredients.
Sounds good to me. I'm hopefully also to our stakeholders. All right. I do not see any further questions. I'm waiting to see whether somebody else squeezes one in before we're dropping off. Anything else that is on your mind, Aaron, that you want to add?
Maybe I'll just quickly mention here that, again, this next version isn't finalized. We do have a GitHub webpage where people can go and request features. The plan for version 5, or I shouldn't have said version 5, but the plan for the next iteration and the next iteration after that. So there's 2 iterations. The next one is where we support Mac computers, and the one after that is where we start incorporating new signs, new methods, and new features. If there is something you would like to see in this next iteration, maybe you can go to GitHub and create a feature request. And if it's a small ask, if it's not too much time to implement, we could perhaps include this in the next release. So there's a window of opportunity for people here to request relatively small features to see them in the next release, but for bigger features, those will be postponed until the release after this release.
Awesome. Thank you so much. I do see one more comment from John Russell. Cannot rename the name of the diet either, it seems. That should be possible too.
So in version 4, there's 2 classes of diets. There's system diets, which are created by the team here. And then there's user diets that the system allows you to create on the fly. And so with those on the fly user custom diets, you can create a diet and rename it. But if you are clicking on or selecting a system diet, we intentionally remove the ability to rename that diet just so that we can troubleshoot issues with people's farms where they're using a custom diet or a system diet. It just makes it easier for us to understand what's going on. But if it truly is not letting you change the name of a custom diet that you just created, you can contact me or GitHub, and then I'll find out what's going on.
I think he managed to resolve the issue. Clarence Further is asking, will water usage be included in the next version? Not in the next iteration that Aaron is working on, but basically that second one after. We currently have a letter of intent in our internal system where we're basically proposing to include the water budget in the Holos model. This is right now primarily for the cropping side of things. We will then have to, if we're going forward with it and we get approval to go forward with it, we'll have to figure out basically then the water consumption of livestock in addition to that. And I don't see any other questions. Aaron, I would say we close this up for today. There is opportunities for people to get in touch with us. You have seen the Holos email. You have the GitHub repository. There's a discussion forum there. Plenty of opportunities. Or if you want to discuss something, ask for a Teams meeting with us, and we can certainly accommodate some meeting with you. With that, I will basically let you go. If you stay on this call webinar, you will be automatically be moved over at the end of the hour at 12 p.m. CST, or in my case, it's 11 a.m. because we're on Alberta time, to the Ted Poyser lecture in soil health that is taking place in person at the U of M. The presentation is being provided by Joanne Whalen, James McGill Professor Research Chair at the McGill University. And she is going to talk about soil health for monitoring agronomic gain perspectives from West Africa and the Sahel. You do not need to worry about basically getting back to the sustainability conference. That will happen automatically. You can ask questions in the chat through the Feedloop portal, and they will be transferred over to the Ted Poyser lecture. At 1 p.m. CST starts our student video session, the second one in our conference. Please be present, listen to what the students have to present, and do keep in mind how good they present for the People's Choice Award tomorrow. There will be a third student video session right after, before we then head at 2 p.m. CST into our second panel of the conference, this time on the topic redefining sustainability beyond greenhouse gas emissions. Until then, we'll go into break. Thank you all for being here. Thank you, Aaron, for leading the training. Perfect training as always. Thanks so much for all your interest and the questions. And I'm hoping we could answer your questions to your satisfaction.